Okay, so now you know more than you ever wanted or needed to know about flags and conditional jumps and such, so we can move on with our lives, I guess. Now, a few things here, like here I added this loop, so now it loops around in this area, right? So that made this obsolete, unless, of course, I was actually going to use this as a subroutine, where it would be from up here, we're going to say jump to, I could just print binary there. Yeah, enter, yeah. Okay, and then we'll say end of program here. So this also does not need to be here. We'll put it here, end of program, like that. The other thing, before, let's see, I was going to just flow through here. Let me do another thing here. Print one label. There, I'm just creating an empty label. Not jumping to it or anything. I'm just using it like a comment, but not matches the other one. Yeah, nice and neat. Okay, so here we have a condition. We jump over print 1 if it's 0. And then after that, we no longer need to call the print character because it can just flow through. Now, I started to do that before when I was setting it up, and then I looked down here and there's that return, right? And I was like, oh no, I'm going to need that. But in this case, no, because as you can see, now it flows through, you set the value, and then it goes right on through down to there. Yeah. In both cases, yeah. And it'll loop, and so no longer needed here, right? Oops, what did I accidentally set up? There, I don't need that. No longer needed here, if it was just flowing straight through like that, it'll end the program, but if you call it, jump to print binary, call print binary, now it'll treat it like a subroutine. It'll jump down here and go all the way to the bottom. Now the return is useful because after it finishes looping the designated number of times, 16 times, this loop 16 times, it'll come out of there, and that end of program now it returns back to where it left off, where you called it, and then ends the program there. So now I have kind of completed the bit where it actually gets turned into an actual usable subroutine. See? Okay, so now that we've done that, you can always save that as something you can use. And so I'm going to do something completely different. I don't need any of that. Just my little boot sector magic gnome stuff. And basically going to start from scratch. I want to work in text mode, just your basic text mode, which is by default 3. But I want to clear the screen right away, so I can go move AX3 and then call that interrupt, video interrupt. Okay, so that will clear the screen. Let's just save that. Do this in bits. There, clears the screen. No, we don't have default text on there. Okay, move. I want to put a go to video mode. So I need that value so I can set the pointer for the video segment. Okay, that would be 0. I'm sorry, 0B800H. There, it's in hex. So now that I have my value set, I can load it. I can go ahead and set my pointer. Move. Yes, my index, my segment. Yeah, segment. Video segment. And then now that I have that, let's set the index, the offset. Why I have trouble with those two terms. Segment, offset. We'll just start at 0. Good. Okay. So next thing. So whereas before, we started with a value in say the lower register of A is good. Yeah, just a generic value in the register, and then we pumped those into our teletype. This time I'm not going to invoke the teletype. We're going to deal with the placement of the characters a little bit differently. You recall in the pixel tutorial where we used your segment offset index. Yeah, we are going to use a similar thing for the placement of our characters. So we'll use the ES and the DI that we just set there, like that. Yeah. There. So we have whatever set up video segment, right? And then character. Now let's just let's test that real quick. Yeah, okay, so we have our character. It's got some default strange colors in there because we haven't specified any, so we can just go ahead and do that. Make a long story short here. So that's stored in the higher register, MOVAH. So I can go like here, OB1. OB1 Henobi, I guess. 0, not O. The joke doesn't work if you do it the other way. MAL. Oh, okay. Yeah. Let's try that for starters. See what happens. Now we've changed the color somewhat, but let's get a little more customized here. You'll call in our what is it? Flags, video modes. Hang on, VGA color palettes. Thank you. Sorry. Here. There's your color palettes, limited, that you have to work with, from 16 colors from 0 to F, or 0 to 15, whichever way you want to look at it. But if we're using the F, it's convenient to work in hex. It wouldn't make a lot of sense if we did it in decimal when using a foreground color and a background color, right? So let's say we wanted red background and a green character. So it would be 4A in hex. Yeah. Let's see here. Just 4A in hex. Here. 4A in hex. Whoops, I didn't save. My bad. What did I do? 4A save. There, so I got the red background with the green character, right? So next thing I want to do, I would like, I'm going to just copy all this bit for a second here. Copy. Like so. Okay, and so and now that just for the moment I'm going to comment this working bit out, and I'm going to work from this. Okay, so in addition to, you know, we have our various characters. We went through them. One of them that we can use, I believe it's character 219. Let's have a look. Is like your block character. Yeah, it blocks out the whole thing there. Okay, so in which case, actually, we didn't really need to worry about the other value for the background color. It's just a single color. Works fine. Okay. Now, what I would like to do is fill the screen, right? You may recall our repeat, where we went repeat string operation, like that, and it's SW there, and then you have to specify a number of times. So I'm gonna move into CX, my counter. Let me just start with 1 here, see what happens. Make sure everything is kosher. Okay, no, it isn't. Okay, there's a little bit of residual there. I believe I can take care of that simply by saying after we're done here to don't do any more. Let's see if that fixes a quick fix here. It is indeed. Okay. Good. So far, so good. Okay. Now, the next thing I'd like to do, so now there I've got a quantity counter. I can put like 8 here now. There, I got 8, or was it, what did I say, 80 across? 80 characters across. We're not counting in pixels here. So, yeah, 80, is that correct? Let's find out. Yeah, and that fills the screen up, the top row, right? So if we want to go down, that's a fairly large number. We don't have to. I know it's 2,000, I think. 25 there, times 25 down. Characters down, because they're taller than they are. And taller than they are wide. There we go. Okay, so that fills up the whole screen. Nice. So now, just let's uncomment for starters here. Let's see. That fixed that, but that's, I think the problem was here. DI. I'm going to want both of these, so I'm going to go try something here first. When you call your video interrupt, it uses a few registers of its own and then doesn't clean up its mess. You know, it destroys a few things, and DI is one of them. Also, your stack pointers. You know, if you've set up a custom stack or something, that's gone. You know, you have to redo that, or you know, so you can't store it on the stack. Okay, so The only thing we haven't defined here, I guess, is DI, move DI somewhere. Okay, I'm just going to say move DI, comma, 4, and save. There. Okay, now, thing about this can throw you, okay. We did the background, it was 80 characters across, but your text character takes up 2 spaces, right? So I put in 4, and what I got is, remember it's starting at 0, 0, 1, 2. Okay, it's not a problem, it's just that everything, here, let me show you. If I were to put 5 in here, everything, each character takes up 2 spaces. So, you know, I get some weird garbage after the character there. It's like incomplete next character or something, because they each take up 2. So you could think of it this way, that every whatever is in multiples of 2, you know, so like 0, of course, is still 0, you know, but if I go 1, if I want to be in the first slot, it's 1 times 2. If I want to be in, say, the 4th slot, now it's actually 4 times 2. See, now I'm in the 4th slot. So if I wanted to be over here, it'd be 80 times 2, I guess. Or it would be 79 times 2, let's see. It would be 79 times 2, and then 80 starts in the next one there. Yeah, of course. So. But you kind of get the idea. So that's multiples. Now you got to kind of watch when you're dealing with like these big numbers and stuff. I'll show you. So I want to be in the middle of the screen. It's 80 by 25, right? 80 by 25 characters times 2. Yeah. Let's say, save that. I'm just going to do this in steps. Oh, and something went awry. So yeah, you gotta watch when you're dealing with these video numbers that you don't end up writing some video intended for video into some other part of memory, you know, into your system or something, overwrite something unintended, right? You gotta keep it in range. Let's see here, 80 times. I went slightly 1 off the screen. I'm not sure, but it should have been halfway. Yeah, halfway, and then the other. Okay, now this is the interesting part. Okay, so I want to go 80 times halfway plus the other 40, right? Okay, no. But order of operations, that's not 100% correct where it ended up. That's because, you know, the multiplication first, or 80, right, here's my, well, actually, so if, to make it work, to make a long story short, I could do a better illustration, but I'm just going to save some time. There, this is all a single calculation before it gets multiplied. Yeah, let's see what happens here. Yeah, so it's closer down to the center of the screen, you know. So the thing to remember about order of operations, you know, you got, the thing to remember about order of operations. Sorry, I had to mind melt trying to explain it for there for a second, is if, let's say, you got let's go 2 plus 6 times 5, you normally think in school, okay, you go 2 plus 6 is 8 times 5. Let's actually make this 10, 2 plus 6 is 8 times 10, is 80, right? But no, there's an order of operations. This will get multiplied first, which is 60 plus 2, resulting in 62. So that's quite a bit different. To circumvent, things getting multiplied or whatever out of place, you can put them in brackets like that, and that groups it before the whole group gets multiplied instead of, whatever. I won't go too far into that. I'm hoping you might have had a basic introduction to some algebra. Okay, so there, character in the middle of the screen, right? Okay, so yeah, like I said, you got to watch with these big numbers. You don't multiply the wrong way and end up way over here, and then you're actually overwriting, your own code somewhere, Okay, so we'll resume in the next video.